Going on, guys. Let's draw the Lewis structure and analyze these molecules right here. So let's begin with the CH4. So first CH4, right? We have CH4, and to draw the Lewis structure we have to know the total valence electron. So let's count it. Carbon has 4 valence electrons and each hydrogen has 4 valence electrons. This is going to be 1 times 4, and that's going to give us total of 8 valence electrons. So whenever we have multiplication of 8, we know that there's no lone pair, and if you draw the structure, this is gonna look like this: C H H H H. Since we don't have any lone pair in the central atom, we know this is gonna be a tetrahedral shape because we have 4 groups. If you count the bonds right here, 1, 2, 3, 4. So this is going to be a tetrahedral, and that's going to be its molecular geometry, right? Tetrahedral. And also we don't have a lone pair. That means our what is that, electron pair geometry, right? That's also going to be tetrahedral. So this is molecular geometry and electron pair geometry. Both of them are going to be same. And let's see whether it is polar or non-polar. Whenever we have some molecule with carbon and hydrogen only, that's always non-polar, because you can assume that this is symmetry, but even if it's not symmetry, if you look at the electronegativity difference, delta En, the carbon has 2.5 electronegativity and hydrogen has 2.1, which is less than 0.5, right? Whenever we have something like this is 0.4, this is less than 0.5, therefore this is non-polar molecule, so this is non-polar. And let's see, and also if you want to look at the hybridization for carbon, this has 4 groups. So whenever we have 4 groups, that is sp3. So carbon is sp3 hybridized, and hydrogen has only 1 group around it, so that's going to be S. And if it's 2, it's sp. If it's 3, it's sp2, and so on, right? So it goes like that. Let's look at the next one, NH3. We have NH3 right here. So let's calculate the total valence electron. Nitrogen has 5 valence electron and each hydrogen has 1 valence electron, so this is going to be 1 times 3, and if you add them together, that's going to give you 8, right? And this is a multiplication of 8, but since we have hydrogen, we can't really say there's no lone pair, right? If there is no hydrogen and we have any other atom, we know if we have any multiplication of 8, there's no lone pair. But here we are going to have lone pair because nitrogen, we are going to have 3 hydrogen right here. Whatever else remaining, that's going to be a lone pair. So we have 2 lone pair right here, and total is 8. 2, 4, 6, 8, right? So that's how it's going to be. And this is polar because if you look at the shape, this is not symmetrical, right? If it's not symmetrical, it's always polar. So this is polar. And also if you want to calculate the electronegativity difference, nitrogen has 3.0 and hydrogen has 2.1, and the electronegativity difference is delta En, that is going to be 0.9, right, which is greater than 0.5, therefore this is polar. And this shape of this one is going to be, molecular geometry is going to be trigonal pyramidal. So this is molecular geometry. If you want to calculate the electron pair geometry, you have to look at the groups around it. If you look at this one, we have 1 group, 2 group, 3 group, 4 group. We count the lone pair twos, right? So this is totally 4 groups. It means this is going to be tetrahedral. The electron pair geometry is going to be tetrahedral, right? And also we have CO2 and NO2. So let's analyze those two molecules, CO2, NO2. CO2 is polar, CO2 and SO2, right? CO2 and SO2. CO2 is polar, SO2 is CO2 is non-polar, SO2 is polar. The question is why? Why is not this is not non-polar, right? So let's see why is it not. If we draw the Lewis diagram for CO2, this is gonna look like this: carbon double bond O, and oxygen is going to have two lone pairs, and other oxygen also going to have two lone pairs. And if you look at this one, this is symmetrical in both ways because we have same atom around the central atom, and if you draw symmetrical lines, this is symmetrical in both ways. So this is non-polar, and also non-polar. And if you want to calculate the hybridization for this one, this is going to be sp because we have two groups around the central atom. This one is one group, this is two groups, so two groups around it, so that determines this is sp hybridized. sp hybridized. Let's look at the SO2. So to draw the SO2, we have to first calculate the total valence. Sulfur has 6 valence electrons, and each oxygen has 6 valence electrons, so 6 times 2, that's going to be 12 plus 6, 18, right? So now if you want to look at the lone pair, if you want to know the lone pair of the central electron, what we can do is we can look at the multiplication of 8 near to this value, like 8, 16. 16 is near to this, 24 is more than this, so 16 is near to this value, 16, and if you deduct this one, that's going to give you 2. So we have 2 lone pair electrons around this central atom, and if you show the structure, that's going to look like this: 2 around this one, and we are going to have oxygen, oxygen, and each oxygen share 2 electrons already, 4 left, so 4 are going to be like this. And this shape is due to this one lone pair electron, these 2 oxygen are pulled down, right? Because we have a lone pair. So this is not a straight line, and if you want to look at the symmetrical, this is symmetrical in this axis, right? But this is not symmetrical in this axis. That's why this is polar. So this is not symmetrical, so therefore this is polar. And also if you want to calculate the electronegativity difference, you can say that oxygen has 3.5 and sulfur has 2.5. If you calculate the electronegativity difference, that's more than 0.5. That also determines this is polar. And what else? That's all about it. I hope you guys found this video helpful. Thanks for watching.